Last lesson, we were working on completing the square on this thing over here, and we managed to rewrite this like that. That's as far as we got last lesson. What I want to do now is I'll do another couple of examples of these, but I want to ask now, what does this mean graphically? So, for example, if I asked you to sketch y equals x squared, hopefully you could all just do a little simple sketch of what y equals x squared looks like. Okay, can you do that? Sketch of y equals x squared. And all I'm looking for is something like that. Okay? Now, what we want to do in a minute is do a sketch of this curve up here. Okay? So we're going to work out what does this look like, where is it, what are some of its important coordinates. So if y equals x squared looks like that, looking at the x in here and the squared bit, this graph has got an x minus 4/3 all squared. We're going to do this in bits. If we know what y equals x squared looks like, what does this one here look like? It's got a minus 4/3 there in the brackets. What does that do to it? Should have covered this sort of thing in GCSE, transformations of curves. You might have done it with sine and cosine curves, shifting them up and down, left and right, stretching them. So all that sort of stuff. Did you have a hand up over here?
Does it like move?
Which way are you going?
I'm not really sure.
Okay. Do you know if it's up, down or left or right? Can you reduce it at all to any of those? No. Okay. Yeah?
I was going to say to the right.
To the right. We had a hand up over there.
I was going to say it was going to the left.
Okay, so we got a left and a right. Did you have a hand up earlier?
Well, if it's minus 4/3, it will move to the right.
He's correct. Okay. A negative 4/3 will move it right 4/3. It's a bit counterintuitive the first time, but a minus inside the bracket shifts it to the right. So that's a negative sign inside the bracket moves it right. Okay, if you want to sort of put that down. So this curve here moves right, so it's the same shape, but its bottom point, what word beginning with V am I going to use instead of calling it its bottom point? It's vertex, yeah? Its vertex, what's the coordinate of its vertex going to be then here in this one?
4/3 and 0.
Yeah. Okay? So, you did this in GCSE, but I'm quite prepared to hear that half of you have forgotten it or it's in the dim and distant past. So, we have dealt now with that minus 4/3 in the brackets. Next thing that's happening is this minus 25/9. So I'm going to put down what we have just got, but what I'm interested in now is what this minus 25/9 on the end does. Okay, if I go off the board and you can't see it, just shout at me and let me know. So this minus 25/9, what is that going to do to the drawing we have here? Go on.
Move it downwards.
Move it downwards, correct, yeah. So if you've got a negative stuck on the end, a negative on the end, that moves it downwards. It's going to move it down 25/9. So this 4/3 to the right is going to be important, but it's going to go down. So the coordinate of the vertex, are you Daisy?
No, I'm Catherine.
You're Catherine, okay. Yes, you are Catherine, you're quite right. Are you Gracie?
Yeah.
That's right, you're Catherine. Right, what would the coordinate of this vertex be now?
4/3 minus 25/9.
Yep, that's right. Okay. So, we've got that. Okay. Now, what's gone off the top of the board now, but was our sort of answer line from last lesson, what was in our answer line that wasn't in this thing here? Emily?
3.
A 3 at the beginning. So now what we're going to do, I'm going to rewrite that again. But there was a 3 at the beginning, which was timesing by the whole thing. And what we want to know now is what that is going to do to the curve. You said the word stretch. The word stretch is correct. So now we come back to what sort of stretch? Vertical stretch, yeah, okay. So a 3 here, a 3 multiplying the whole thing, that 3 there, is a vertical stretch, scale factor 3, so that from the x-axis. So everything basically is 3 times as far away from the x-axis as it used to be. So, this one here, is the 4/3 still going to be important? Yes, it's still going to be, the x-coordinate of that vertex is still going to be 4/3. But the y point here, this will no longer be 25/9 below the x-axis. It will be 3 times as far away from the x-axis. What is 3 lots of 25/9? You've fallen into a trap there. Go on.
Would it be 75?
Yeah, remember, just times the top, not top and the bottom, just times the top. It is that. Would anybody like to give me that y number there, that y coordinate in a different way?
25/3.
Okay, yeah, or minus 25/3 if you cancelled it down. I'm really not fussed at the moment which one it is. But yeah, multiply it by 3.
Why did the 4/3 stay as?
Because that was a vertical stretch. It wasn't affecting anything to do with left or right
How do you know?
from that point down there.
How do you know which one's vertical, which one's thing again?
Okay, so if we just go, the more you do, the easier we'll get. But let's just go through, if I can sort of zoom out on the whole thing.
So, can I put on the bottom side?
Yeah, absolutely, that's fine. Okay, inside a bracket, if you have a number inside a bracket which is plusing or minus, a minus in there shifts it right, a plus in there shifts it left. Then the next thing was something tacked on the end of a bracket always shifts it up or shifts it down. And if you multiply a whole thing by a number, that's always a vertical stretch. Okay?
Oh, so if you were to have like 3x in the brackets, would that be a horizontal?
Yes, if it's inside a multiplier inside the bracket, yes, that's the horizontal stretch sort of thing. Well, I'll clarify that later on, but yeah.
So you can get whole, like, width stretches.
Yes, you can. You can, but we haven't seen any here at the moment. Okay? Right, has everybody managed to deal with that one first time round? Don't worry if you don't get it straight away. We've got 2 more examples coming. Okay? So, I'm going to pause the video. Good place to probably start a new video.